here to welcome our next moderator and speaker. So we are joined today by Shikwan Chen, who is currently the Chief Design Officer of Compal Electronics, a company which is responsible for a quarter of the laptop computers built worldwide today. He leads a team of more than 350 computing and communication mobile device design experts. Shikwan serves on design competition juries internationally and teaches part-time at the Taipei Shixian University as well. Shikwan currently also serves as a consultant for governmental organizations in Taiwan, including the Taiwan Design Research Institute, TDRI, our member who helped put this session together. So many thanks to them. And is also a regional advisor of WDO, as well as an ambassador of Good Design Award Australia. So welcome, Shikwan.
Thank you, Natalie. Hi, Anju. Long time no see.
Long time no.
Yeah. Hi, designers and friends all around the world. It's 29th of June today, the World Industrial Design Day. And if you just happen to join this program this very moment, you might like to know that the World Design Organization has made extra effort in arranging non-stop, all day, 24 hours of exciting design sharing talks and dialogues with famous speakers all around the world. And this section now happening in Taipei, Taiwan this moment. We are 12:30 noon local time here. And I'm very excited to introduce you Mr. Arthur Huang, whom is our guest speaker for this section. Arthur is a structural engineer, architect, and leader in circular economy innovation with Ewaste, a trash material technology company he started in 2005. And the mission of Ewaste is to upcycle decades of single-use environmental pollution into sustainable smart building solution of the future. And under Arthur's leadership, Ewaste has received numerous international invention patents in manufacturing processes, as well as mechanical assembly to enable circular economy and consumption. Also, Arthur was recognized by various international institutions, including the World Economic Forum's Technology Pioneer Award, Obama's Emerging Leader, the Financial Times Earth Award, and the Wall Street Journal's Asian Innovation Award. In February 2019, the World Economic Forum named Ewaste as one of the top 11 companies leading the way to a circular economy. So hereby, ladies and gents, I'm very pleased to present you Mr. Arthur Huang, the founder of Ewaste. Arthur.
No, thank you, Shikwan, for the kind intro. But I just want to get right down to the urgency of the business of trying to solve the single-use trash issues that's killing us around the world. At least to me, it is. But I think there's a huge urgency. So I think if you, I think all here are design professionals. So I think we don't need to talk about the urgencies and the problem that we all face. We all know the material is not going anywhere. It's going to trash. Okay. And it's polluting the environment, it's polluting the ocean, et cetera, et cetera, et cetera. And this includes our electric car, lithium batteries, how we collect cobalt, et cetera. Okay. So I go straight to the solutions that why diversity is important and how decentralization could potentially be the only way to help to resolve many of these issues. And some of the presentation that we are showing now is something that we are already executing and we are actually moving towards. And some is not yet executed at the scalable level, okay? But I'm just presenting you a 3 level of solutions that maybe we can use that as a food for thoughts for your endeavor in your design field in the future, okay? So let me right now share the screen. This is what we mean by a road to transformation. Try to turn all our existing waste material into valuable products, but in a decentralized, diversified way. Okay, we are looking at 3 phases for all those who are designers, engineers, and design professionals in the urban sense. Everyone talk about the future of infrastructure developments, which is all kinds of giant recycling system that's able to turn e-waste, food waste, all into new material. And this is what we mean by the last phase. So I will start with concentrating on the phase 1 and phase 3. 1, 2, 3. Okay, so there is a lot of diversified creativity around the world. Okay, our trash problem actually is universal. Okay, so we are able, I think the first phase is to create these very tiny solutions to show, that's phase 1, what we call a decentralizing robot. Okay, trash robot. We basically package this universal problem we have, we put it into different creative communities, diversify around the world to solve the same type of issues. So you have a very low cost, low barrier to entry first stage and second stage to demonstrate to the public, to gather the necessary creative and community action plan, and to make placemaking projects together. Okay, that's the first thing. To demonstrate it can generate money, it can generate traffic. You actually gain benefit from decentralizing and transforming, upcycling all these materials. Phase 3 is then to get it to a city scale level where you're having these hubs where factories move back into the city centers, okay, and where transformation happens locally. As you guys know, if you actually ship trash around, none of the circularity and none of this recycling makes any sense because it's all huge carbon footprint, toxicity footprints, pollution footprints again. Okay, and then you are actually damaging where you're actually living. Right now, we are damaging where we are not living. Yeah, so all this process is actually designed to have almost zero footprint and zero pollution footprint too. And the last stage is that then you can scale that when you know each individual area, what they are actually good at, then you can scale some of a recycling infrastructure that can be shipped around after it's being transformed into a final product. Okay, and this MiniWiz has built a lot of. We have built e-waste, food waste, single use PET waste, all the way to car waste recycling system. Okay, so that part I actually are not worried about for any of a big company to invest in. So let me start with first phase and second phase. It's called Mini Trash Press or Decentralized Trash Robot. So let me show you a 2-minute video just so you can quickly understand what that system does. Just watch the video, right?
Arthur, because your headphones are plugged in, we actually cannot hear the audio on the video.
Okay.
A modular system with a smaller footprint for easier transportation and higher energy efficiency. With a new system of heat induction presses and specific molds for different parts, the process has become faster and more efficient. The new Trash Presso complements Robin, MiniWiz's smart trash collection system. We will track every single piece of your trash from the moment you throw it away till the time we put it back in the game. Furthermore, new Trash Presso can be upgraded with a robot arm that will do the dirty job. technology, engineering, design, ingenuity, creativity, and passion.
Oh, okay, can I get back? Okay, so I just want to quickly explain how we are doing this. We basically started a store in Italy and Sardinia to collect the data. I know like this is kind of funny that you start a store to collect the data because you want to know what type of material is being collected from different places, from ocean cleanup all the way to a post-consumer at a restaurant or at a shopping mall. So this is where we are actually locating the machine and the solution with the camera. When you come in, you already know what type of material you want to recycle. And directly you show people what the potential can be, from the lamp to the structures, to the tables, to the shelving system, to all the products in there. So you have to trade your trash, okay, and turn that into a digital point. Then you can buy anything that's inside the stores with these trash points. And this is why we trade them for the data. Okay. And then on top of that, there's a whole process of education and linking with different designers that we're collaborating with. The designers could be industrial design professionals or literally kids and adults. So they are able to mix their own trash together to create different colors, different textures, with different molds that and integrating with the robot at different settings. They can create all kinds of different products literally in 2.5 minutes, from architecture joints to flooring mosaic tiles, and all the way to a cup or a bowl or a collar for your dogs. This is what we mean by local decentralized solution, working with local designers and with these diversified source. Sorry, let me go back a little. So you see all that black plastic that you see there is actually indigenous to Sardinia. You will find that very funny. Why is that indigenous to Sardinia? Because Sardinia and Portacevo is one of the most expensive yacht club in the world. And they ship vegetable in these black PP containers, okay? And they are not recycled. And this is kind of very scary. So just imagine all these fancy yachts that one of the highest industrial design products there is in the world. They're constantly bringing single use for all the fresh vegetable, waters, etc. And we are recycling huge amount of these black polypropylene, okay? And we are mixing them with different bottle cap to get different colors. And so that is, we are working with the local artists to come up with a mosaic that become the boardwalk for the actual yacht club. Of course, these decentralized solutions show people what potentially can be, because a mosaic, a piece of art, or a actual single pot for a bowl for your pet actually has a value, right? So right away, we wanted to show people all that trash that right now there's no value has a value in the system. The second level that we actually have, and we have this in Taiwan, okay? But we are scaling that very soon, hopefully, in some of the world events. So this is what we mean by a micro plants. It's a co-working micro plants where we work with further take the different type of technology from fabric waste, metal waste, all the way to single-use plastic waste and building site, what we call dismantling construction waste. Okay, we can turn that into products with local designers and operators. So this is a conception of what it can be at a very tiny site with all the different required technology. On every box pretty much is a set of machines that MiniWiz already designed. And this is the one we are actually deploying, and you will soon see this quite a lot. And we are putting that on a barge, okay? and where the recycling lab can actually be moved around and can collect all kinds of material. And by the way, this is actually a real project. And I just can't say where it is going to be yet, but it's going to be there very soon. And it will have all the manufacturing machine, including a plasma coating machine. A lot of people talk about adding performance to materials, to trash material. We find that in a very small footprint, low energy consumption, you can use plasma to coat to create antibacterial, antiviral material onto any type of substrates, okay? Hard material and soft material alike. Okay, so this is quite an interesting development for us to show the real possibility of turning that into valuable products. And then the last level is obviously the craziest full-scale recycling campuses, but this requires collaborations on multiple levels. This require government certifications. They require all kinds of remediations on the site. So I think this is a much longer game, and you need to develop a business plan in order for this to work. Otherwise, it's just a fake project. So, and we actually are in the first 4 years of MiniWaste, we built 4 of these plants, including one of the biggest e-waste recycling campus and one of the bigger car waste recycling campus, including taking away batteries, including taking away precious metal parts. I was going to give you examples of what we did in Singapore this time. It was not executed fully, but it was actually already implemented until the COVID hits the construction worker camp. Okay, then the construction stopped. Okay, so all the machineries was designed to recycle a specific waste called PPE waste, which is all the medical waste that's coming online. So we basically have a sterilization module plant, and then we combine that with a larger scale trash lab optimized for turning these non-woven material back into mechanically recycled non-woven, and we roll it with a structure on top of that, a mechanical structure, which is ultrasonic or supersonic stitching, and we added a heat roll on top of that to create certain type of tensile strength that's needed for the new fabric, and we coat it with a plasma. So then you can get to level 1 to level 3 of PPE again, the new medical grade textile again. Or during the non-pandemic period, then you can turn those material into antibacterial viral repellent architectural panels for hospitals, or architecture fixtures like chairs and insulation panels for all the design applications. So this was also designed in a modular way to scale also during the pandemic. Just generally give you an idea of what that is. And these are the processes that we also design with the machinery that go with that. So this is just giving an idea of the type of e-waste recycling plant we built. And you can see the handrails, the curtain walls, the canopy systems. They're actually all already made from e-waste. So whatever that's waste of an e-waste plant, we're also using that to build the plant itself. And food waste recycling plant, car waste recycling plant, this is finished. And last one, I would just want to give you guys a brief intro so we can have a conversation. During the pandemic, as you know, most of our project internationally is grind to a halt. There's no international travel, materials and scarce resources. All the manufacturing plants shut down. So what we did is we built, we're approached by the government and the Fujian Catholic University Hospital to build a modular ward system to combat the pandemic. So lots of modular ICUs, negative pressure in isolation rooms. So this is the result we did last year. And now this is a prototype, and now it's deployed into 93 beds at a hospital extension of the Catholic University Hospital, and currently is in operation just about 2 weeks ago. And I just want to point out to some of the innovation that happens here, because during the pandemic, you're unable to ship internationally. So we had to use local trash resources. So Taiwan was blessed with a very strong aluminum recycling system from its electronic industries and all the machine building. So we have so you see all the white panels that you see here, they are all made from recycled aluminum, coated with the antibacterial, antiviral paint. And on top of that, all the joint system actually is designed to be quick fix and quick install, and also is very pressure tight, airtight. So you are able to convert these rooms quickly into negative pressure and positive pressure surgery rooms. And these are what we call a modular boards, and with a joint system. And they can be because of this dry construction, I would call it. You can see that you can integrate with all kinds of new technology on this new platform. So hopefully we get to work with a lot more technology professionals around the world. We work with GE, we work with ASUS, we work with Taiwan's, like lots of even the smart power control. And because of this dry construction, you're able to lay all the medical infrastructure behind it, and on top of the new generation of digital infrastructure behind it, okay? And at the same time, create an airtight bubble that hit all the building criteria of safety and health safety, and the cleaning safety and the operational safety that's necessary for the challenges we face. And this is all made in our trash lab in Taipei, which is that urban hub. And you can imagine such a small, tiny factories, you can build so many things. And so with all the new digital technology, this is it. Yeah, I think this is kind of our way of showing trash. By the way, all the panels, all the joints, they are already all made from medical recycled PPE, and the panel itself is made from recycled aluminum. Unfortunately, the floor is made from PVC. Obviously, it's medical grade too, but then because of a fire rating, so we didn't have enough time to do a new type of flooring material, but everything else is done by us. If you notice the handles, the hinges, they're already made from recycled mask and PPE. The last is just a 2-minute video of what Ewaste has done. So give you an idea, the journey took us this long is because we have done so much diverse projects, from working with fashion brands all the way to working in architecture and recycling infrastructure. So hopefully we can combine that diversity and working with local diversified group of creative professionals. We can continue to continue this journey of upcycling any type of single waste out there. Okay, so I need to I need to take this out.
We want to matter. We want to matter to the non-toxic future of our world. We want to matter to the sustainability of our community. At Ewaste, it is our mission to change consumer behavior into a circular one. It is the only way for us as a species to sustainably consume our limited resources. Overconsumption is a complex system problem. There is no single miracle cure. We want to matter by proving human consumption can be satiated with our very own trash. We have dedicated ourselves to turning decades of environmental pollution into solutions that will enable us to live sustainably. We want to matter, so we turn ourselves into magicians of trash, inventing new ways of transforming our everyday trash into high-performance works of art. We turn milk packaging into the hottest sportswear fashion. plastic bottles into luxurious textile, cigarette butts into furnitures and glasses. We want to matter, so we infiltrate the cities where the desire for luxury is cultivated. In Milan, in Berlin, in Beijing, in Taipei. We want to matter, so we design scalable technology, machines, softwares, utilizing the material and carbon footprint that we have already created. We research new ways to reuse trash, localized collection for turning waste into new products. To date, our lab has innovated over 1,200 new materials made from trash to unlock the upcycling potential of everyday waste, available in our cloud material database. We want to matter by giving our future generation hope. Please join us in this trash revolution against our own selfish inertia. Let's stop talking about the problem, take responsibility of our own action, and start doing. Because we all matter.
Thank you so much. Hopefully we can start a conversation, and welcome to shoot us any. I'll give the time back to Shikwan. Thank you.
This is excellent sharing, Arthur. I'm sure many of us have been very inspired. We have probably 2 minutes left, so I just want to squeeze in a quick question and maybe a 1 minute answer, Arthur. As we know, our WIDD main topic this year is about diversity. Hence the question, what does diversity mean to you and to Ewaste, Arthur?
First of all, the problem we are dealing with is very diversified. That's the first thing. Okay. The other one is the creativity, unfortunately, is not very diversified these days. That's also an issue. So you want to have diversified problem, but you don't have, and you do have a general universal problem, but you have a very consolidated, single-minded design solutions that's out there, and that I think is very problematic. That's why we're looking for not centralized productions, but that will kill the business model for most companies. Most company will die because of there's no centralized business model. So how do you build a diversify, engage on social actions to let empower these diversified individual groups to take their own actions? And so we are trying to design weapons for them. That's what we're trying to do. And that's how we can support this diversity going forward.
Thank you. Thank you, Arthur, and all of you out there for joining us this section of the World Industrial Design Day event. Hope to see you all soon, and please stay safe. Back to you, Natalie.
Thank you.
Thank you, Arthur.
Thank you. Thank you, Shikwan.
Thank you both. That was really wonderful. Thank you so much, Shikwan, for also moderating this session.